In this video, I'm going to discuss the solution and scoring to 2019 AB free response question number 4. In part A of this question, you are asked to find the rate of change of volume of water in the barrel with respect to time at this given height of 4 feet. So in other words, we need to find dV dt when h is equal to 4. That's our goal right here. Well, the first thing I notice is I'm given a formula for volume, so I'm going to need to take a derivative of that. Well, if volume is equal to pi r squared h, and I look at my picture right here and I immediately notice, oh, I've got a diameter of 2 feet. That means r is just 1 foot, and it's constant. It's not changing throughout this cylinder, a cylindrical barrel. So I can rewrite this and make my life a lot easier if I say pi times 1 squared h, in other words, pi h. Continuing on, I know that I want to find dV dt, so I better take a derivative with respect to time of this equation. So I'll have dV dt is equal to, and on the right-hand side I have pi times h. Well, that's going to be pi times dh dt from the implicit derivative. H is changing with time. The height right here is changing with time, so we need to take an implicit derivative on the right-hand side. Now, I remember I'm trying to find dV dt when h is 4, so dV dt when h is equal to 4 is going to be equal to pi times then dH dt. Well, what is dH dt going to be? Well, dH dt, they tell me right here, is going to be -1/10 times the square root of h. Well, h is 4, so that's going to be the square root of 4. I'm on the free response, so I'm not even going to worry about simplifying that at all. I am, however, going to worry about this last little bit that says indicate units of measure. Better tell you what the units of measure are right here. Well, I'm change of volume over change in time. Volume here. Volume, let's see. Well, we're talking about a diameter of 2 feet, so our volume is going to be cubic feet. And then the per time, so per, and our units of time is going to be seconds. All right, so how would this have been scored? We're looking at right here our first point coming in. If you had this line correct, you had dV dt equals pi times dH dt. You'd earn your first point, and the second point would come from having the answer correct and having the units correct. You don't need to simplify this. If you do simplify it, that's great, so long as you simplify correctly. But if you simplify incorrectly, this point is going to be withheld. 2 points total for part A. Part B. When the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? Okay, I need to know the rate of change. Is the rate of change increasing or decreasing? Well, the rate of change would be already dH dt. And if I want to know if dH dt is increasing or decreasing, I need to take a derivative of dH dt. So let's see what that looks like. If I take a derivative of dH dt, that's going to be d squared h over dt squared, the second derivative now of h with respect to time. Let's see what happens when we do that. Okay, so I have -1/10 times the square root of h. So the square root is 1/2 square roots of h when I take its derivative. So that's going to be -1/10 times, I just said 1/2 square roots of h. That's the derivative of our square root function right there. But I can't forget that I need to multiply by the derivative of the inside. Well, what's the derivative of h? I'm taking a derivative, remember, with respect to time, so that's an implicit derivative. Can't forget about the dH dt right here. Okay? Cool. I found the second derivative of h with respect to time. I've got it all nice in here, but I have a dH dt on the inside of that. Let me plug in. I know what dH dt is. They gave it to me up at the top. So what I actually have right here is, let me do a little bit of simplification too. -1/10 times 2 would be 20 square roots of h. And dH dt, we just said, all right, I've got -1/10 times the square root of h. I see some simplifying I can do right here. Maybe it'll make my life a little bit easier. That's actually 1/200. the square root of h and the square root of h cancel. One's in the denominator, the other's in the numerator. So 1 over 200, d squared h dt squared is always 1 over 200. Well, remember, we were trying to see if the rate of change of the height of water with respect to time is increasing or decreasing. Well, if its derivative is always a positive number greater than 0, I better tell the AP graders that I know that this is a positive number, then I know that we're going to have an increasing dh dt. So let me make sure I convey all of that and I earn all of my points. So let me answer, hence the rate of change of the height of the water with respect to time is increasing. Okay, and they ask when the height of the water is 3 feet, is it increasing or not? Well, we really know for all times it's increasing here, or at least for all positive times. I don't know that negative time really makes sense in the context of this problem. But it's definitely true that the height is, when h is equal to 3 feet, that this is going to be increasing because d squared h dt squared was a positive number. 1 over 200 is greater than 0. Okay, how would I earn points on this? First point comes right here where I have found the derivative correctly of this function dh dt. And the second point is going to come if I also have the chain rule part correct. So if I have the fully correct answer, then I'm going to earn 2 points for this line right here. If I had forgotten about the dh dt, then I'm just earning the 1 point. But if I have it there as well, I'm getting the fully correct point as well. Cool. The third point then is going to come if I have a good answer, and I explain it as well, so with an explanation. Okay, so if I have a good answer, I explain it properly, I'm earning my final and third point, so 3 points total on part B. Part C. All right, at time 0 seconds, the height of the water is 5 feet. Use separation of variables. Aha, separation of variables. I remember how to do that. That means I need to get my h's with the h and the t's with the t. Oh, I don't see any t's, so dh dt equals -1 over 10 square root of h. I better just get the h over here and the dt with the constant. What's that going to look like? It'll be 1 over the square root of h is equal to -1, oh, I'm sorry, I'm forgetting my dh right here, excuse me, times dh is equal to -1 over 10 times dt. Okay, so on this side, I'm going to be integrating now, and I'm going to integrate on this side as well. On the left, that's going to, if you think about that as a -1/2 power, the antiderivative of h to the -1/2 is going to come from h to the +1/2, but that constant is going to need to be a 2 in the front of it in order to cancel that properly. Okay, so I know that over here I'm going to have 2h to the 1/2. Over on the other side, -1 over 10 times t. Don't forget about your plus c, your constant, your Charlie. Let's see what we can do then about maybe solving for that Charlie. So if I plug in, I remember I'm given this point 0, 5. So at 0, 5, I'm going to plug in. Okay, and at 0, 5, I'm going to end up with then 2 times, well, 5 to the 1/2, that's the square root of 5, is equal to -1 over 10 times, oh, wait, t was 0 plus the Charlie, so I get 2 square roots of 5 is equal to Charlie then. And I'm able to then continue on. Let me come over here with a little bit more room, and I'll plug back in with my Charlie. So 2h to the 1/2 power is equal to -1 over 10 t plus 2 square roots of 5 right there. Awesome. Okay, and let's see, just to finish off, I want to actually solve this for h in terms of t. That means get h equals, well, we're going to divide by 2 on everything. H to the 1/2 power equals -1 over 20 t plus the 2 over 2 would give us just a square root of 5 that's left. And if I square everything, that's going to be the last move. So h is equal to negative 1 over 20t plus square root of 5, whole thing being squared. Let's talk about how points are going to be awarded on this one. The first one is going to come from if you separate your variables properly. Then you're going to get another point if you have the antiderivative, both of these antiderivatives correct on the left and right hand side of your equal sign. If you have a plus c and you use your initial condition, you're going to be getting your third point, and then the last point is going to come from your final answer. So 4 points on that problem. These types of problems are always really heavy. They're always worth 4 to 6 points. Very important skill that does show up on the free response section on most AP exams. Not every year, but most years it does show up on the actual AP exam. Okay, there it is. Thank you for watching. Have a good rest of your day.